Hey everyone, good morning. I am Priyanshi Agrawal and welcome back to my YouTube channel. Now we are going to solve today's Leetcode daily challenge, which is maximum ascending Subarray sum. Okay, so let's see what is this question and how we can solve it. So in this question, you have been given an array of positive integer nums and you need to return the maximum possible sum of an ascending subarray in nums. Okay, a subarray is defined as a contiguous sequence of numbers in an array, and a subarray will be this contiguous sequence of numbers is ascending it for all I where I exists between L and R, and note that a subarray of size 1 is ascending. Okay, so you have been given with a subarray, let's say this, as we can see from first example, and you need to return the maximum possible sum of an ascending subarray. So see, in this example you have been given this array. So this subarray is ascending 10, 20, 30, okay, and this subarray is also ascending 5, 10, 50. So what will be the sum of this subarray? This is 60 and this is 65, and we need to return the maximum of all of them, which is 65. So this will be our final result. Okay, so if we need to find the subarray and then its sum if it is ascending. So what we can do, we can simply find out the first we can go through this array and check out for all the subarrays which will take big O of n square, right? If we want to find out all the subarrays, then it's take n square, and then we can check for whether that subarray is ascending or not, and then we can find its sum. So which will ultimately take n plus n. Cool. Can we optimize it? Yeah, you can optimize it in the way that while checking for the subarrays, you can check whether it is ascending or not, and after that you can find its sum. Okay, and can you optimize it further? Yes. While checking for the subarrays only, you can maintain a sum variable. Let's say you are iterating on this. You have taken one subarray this, and then you can take this subarray. So you are just moving a pointer, so you can keep track of your sum here and then count its value sum. So in this way you can take it up to n square, and as this is an easy question, so it will also work, as it will be 10 to the power 2 into 10 to the power 2, that is 10 to the power 4 only. But can we optimize it further, because n square complexity doesn't look good. Okay, so let's see if we can optimize it further. 10, 20, 30, 5, 10, 50. Okay, so as you can see from here that this is increasing, yeah, but here no, it is decreasing now. So we need to again reset the value of our sum and then again start to counting the sum. Okay, so let's say if we create two variables, that is current sum and maximum sum. So our initially our current sum will be 10 and maximum sum will also be 10, right? Okay, now when we are here, let's say our pointer is here, so we will compare both these values. Okay, so is 20 greater than 10? Yes. Okay, add it to our current sum. Okay, now our pointer is here, so now we will compare these two values. Yeah, 30 is greater than 20. Okay, add this in our current sum. Okay, so it becomes 30, and then 30 plus 30, 60. Okay, now we will compare this. 5 is greater than 30. No. So what we will do here, we will update our maximum sum to the value of maximum of current sum and maximum sum. Well, how we will update it? Maximum of maximum sum and current sum when I is not greater than I minus 1. So maximum of 10 comma 60 is 60, and then we will initialize our current sum with this ith index value, so it will become 5 now. Okay, now let's check for other index again, whether 10 is greater than 5. Yeah, 10 is greater than 5. Let's add it. Okay, now we check for another index, whether 50 is greater than 15. Yeah, let's add it. Now by the end of the loop, again we will check for this and we will update the value of maximum sum. Now it will become maximum of 65 comma 60. Now it will become 65. So it is 65 here, right? So in this example, next example as well, this is continuously increasing. So we have been returning the sum of the complete nums, and in this example you can see this is one subarray, this is another subarray, this is another, and then this is another subarray. Cool. Okay, so let's try code this approach of current sum and maximum sum. Let's first store the size of the nums in n, and then let's create two variables, current sum initialized with nums of 0 and max sum also initialized with nums of 0. Now let's start iterating in our loop in our nums, and then check if nums of I is greater than nums of I minus 1, then only what we will do, we will let's say it's current sum plus is equals to nums of I, right? Otherwise what we will do, we will update the value of max sum and we will reset the value of current sum to nums of I, right? And again also by the end of this loop we will need to update the value once, because let's say if our array is ascending completely, then we have never reached this condition, right? And now by the end of this loop we need to return maximum sum. Let's try run this. What happened? Okay, we have to initialize this with 1. Yeah, it's working fine. Let's try submitting it. Yeah, it's working fine. So now let's talk about its time and space complexity. So as you can see that we are doing a single iteration only, so its time complexity will be big of n, and as we have not used any extra space, so its space complexity will be big of 1. So yeah, this was all about this question. I hope you get it, but if you still have any doubts, then you can post in the comment section. I will surely try to answer them. Till then, bye guys, see you in the next video.